Hello. Yeah, very good evening, everyone. Yeah, good evening, everyone. Allow me a few more minutes. Let's join the rest of the participants. Then we will start with the today's session. Yeah, very good evening, everyone. So, guys, this is Vikas from ISI India. So, we have Mr. Yash in ISI India. Is having an experience for freelancing projects. So, he's doing numbers of projects by using a CAD softwares. So, by today is going to teach us all like for the basics of SolidWorks. So, he will give you the overview of SolidWorks, how we can.
I'm audible.
Yes, yes, you are perfectly audible. You can continue with.
Okay.
Yes, please unmute yourself.
Okay. What is SolidWorks? So SolidWorks is a solid modeling software or solid modeling programming, and it is work in product development and designing, and it is used as a drafting tool use and 2D and 3D designing of any object. Okay. SolidWorks is a 3D solid modeling package which allows users to be develop full solid models in a simulated environment for both design and analysis. In SolidWorks, use sketch ideas and experiment with different design to create 3D models. Industries examples: track bikes companies, design, manufacture, and markets bicycles and bike accessories. Challenges: height and expectations for quality. Uh, Lance Armstrong integrate design and manufacturing, increase market demand. Benefits of SolidWorks: shortened design cycle by 50%, improved product quality, double throughput of new products, 100% increase by providing multiple options for design, manufacturing, and quality control.
Hello, guys. I think there is some net. Just allow me a minute. I am checking with uh, Mr. Yash. Just allow me a minute.
किया है, लेकिन मैं वहां गया नहीं, मुझे बुलाया।
Hello guys, am I audible? Okay. Okay, so Yash is kind of busy right now. He's facing some network issues, so no worries. I'll take on from his side. And moving on, so what SolidWorks is? So what SolidWorks is it's a 3D modeling package. Okay, we can do like what is design? Okay, designing first starts with ideation. Okay, you first you first think that what you want to design, and then afterwards you put that into a 3D perspective. After you design it, after you design it, you have to simulate it to find out if the design is valid or not. If the design is passed, then you go for manufacturing. So SolidWorks helps you in that ideation process, and also it can be used for analysis. Okay, so we can do both 2D and 3D drawing also. Like first we do 2D, first we do the 3D drawings. Okay, and then when we have to create the BOM, bill of material, and bill of material, or we have to give drawings to the vendors also. Then we use 2D sketching in SolidWorks. So bikes, like this is an industrial example. So have you heard about like Trek bikes? So Trek bike is actually a very big company for like building mountain bikes. Not only mountain bikes, they build all sort of bikes. Okay, cycles. So they also use SolidWorks, and what they do is like everything like they integrate the design and manufacturing. Okay, so basically they use SolidWorks for like designing also, and it helped them a lot. So what actually is the benefit of SolidWorks is that it shortens the design cycle by 50%. Okay, so what actually is design cycle first of all? So as I have already told you that the starting of a design starts with an idea. if you want to create something, first you have to like idealize that thing in your mind. Okay. After you idealize it, then you have to give it a rough sketch, a rough, let's say a 2D, or like you have to draw it on a pen or paper, and like so that you don't forget that idea. Okay. So after that, you then do a drafting. After drafting, then you go for the 3D drawings and then simulation and then validation. After validation, when it's completely assured that yes, this product is manufacturable, this product has nice FOS, and this can be can be easily manufactured. Like it's gonna cost low. It's gonna be less in cost. So then you go for the manufacturing. So this is the overall design cycle. Moving on, like it also helps you for improve product quality. How is it gonna improve the product quality? First of all, so have you heard about tolerances? So basically, what tolerances is, it's the plus and minus in anything. Let's say, like if I'm saying a moving piston cylinder. Okay, if I'm saying a moving piston, so this I don't know if my pen, it should be visible. It's not working. No, never mind. Let's go for this thing. Here it will work. Okay. So let's think of it this way, that this is a piston. This is a piston. Okay. And here, this is the piston body. This is the cylinder. Okay. So this piston has to go in and out of this cylinder. Okay. So this piston has should have this, the area of this piston, or let's say the diameter of this piston, should be first of all less than that of this diameter of this cylinder. But it should not be that less that the pressure gets reduced in this entire arrangement. Okay, so for that you have to do a tight fitting over here, and for that tolerances are used. Okay, so it helps you to improve the product quality, and like the everything, like double, like once the product quality is increased, then of course the like throughout the product, like throughout of the project, it's also gonna get increased. Okay. Now, what's like, is SolidWorks essential for you first of all? Okay. So SolidWorks is like used by both, like everyone, like students, designers, and like engineers, all the professionals. Like I can't even think of any industry where I haven't seen SolidWorks being not used. Okay. Any, like, first of all, let me tell you one thing also, that in programming, what people say, that you need to understand with the logic behind the code. The syntax is the same in, like, the syntax is different in all the programming language, be it C, be it Python, be it any programming language, C Sharp, Ruby, any programming language. Okay, the syntax is different, but the logic should remain the same. Similarly, the design intent should be same. Okay, now I'll just give you an example of design intent. Okay, suppose, like, let's open SolidWorks also, and there I'll tell you how, like, what is design intent also. Okay, moving on. So other parts of SolidWorks, like it's used for assembling also. Like you have seen huge plants, like this SolidWorks window when it's opening. Let me like reopen this. Okay, so this, you can see this entire assembly. This is created in SolidWorks only. So SolidWorks has a lot of potential. Okay, and you can do many things in SolidWorks. Now, like these are the like sub components. So when SolidWorks start, this is the starting screen of the SolidWorks. In SolidWorks, it doesn't mean that I can only do these like part drawings in SolidWorks. Individual drawings can be also done in SolidWorks that people usually do in AutoCAD. Okay. Moving on, so SolidWorks part modeling, it's like 2D. First, how a uh, how a part is made. Okay, so first you have to do a 2D sketch of the of the thing. Okay, and then you use feature commands to convert that 2D into 3D. And when we have parts, okay, so just first I'll just this. First is the 2D drawing. Okay. In 2D drawing, what I do, I use features. Okay, okay, this is working now. Pen is working finally. Nevertheless, so in first we do 2D sketch. Okay, and in sketch we do feature. Okay, what feature is, like you can see, like I am right now in SolidWorks game. Okay, I am opening a part. I'm opening a part. So here, like I'll just do it in front of you. I am just drawing a rectangle. This is a rectangle. Okay. Now I am going to this feature bar. I am going to this feature bar. There are multiple features that I can do. Okay. From extrude, revolve, sweep, and many more. Okay. Let's go for a simple extrude feature. When I go for extrude feature, now this 2D drawing gets converted into 3D. Okay. Earlier I just gave a length and breadth. Earlier here I just gave a length and the breadth to the entire section. Now for converting it, I am giving the height also. I can change the height from here, and voila, like this is our 2D, like this is our entire drawing is made 3D in 3D. Okay. For like making it more visible, just a second now. I can do this. Okay. No. Drawing. Display. Okay. So this is the entire framework, okay, which I got in the 3D. Okay, which it has length, breadth, and height. Okay. Now moving on, assemblies. When I have multiple of these 3D drawings, okay, when I have multiple of these 3Ds, I can like do assembly of these 3D over there. Now, and like as I've already told, you can also do drawings also. Moving on, this is the SolidWorks interface, and okay, we can just do now things in SolidWorks itself. Okay, so this is the entire interface of SolidWorks. This is the ribbon. This is the ribbon bar. Here you find all the commands. Everything is present over here. Okay, this is the feature tree. So what feature? I have already told you. These are the features that we can use in SolidWorks. Okay. From like boss base, sweep, everything, these are the features. Okay. Which feature do you use? I'll use boss base. I use boss base here, boss extrude over here. So this boss extrude came in the feature tree. If I use any other feature over here, let's say I am going for a I want to do a hole in here. Okay. So what I'm gonna do, I am gonna sketch and create a circle. And when I'm gonna create a circle, I just created an extrude cut. This extrude cut is here. I used another feature, right? You can see like this is like this entire figure. In this entire figure, I have this cuboid, and in cuboid I have cut down circle. Okay, so this is the entire 3D. For I'll just try to give you a better visualization.
Can I continue, Pushkar?
Okay, yes, you are back. Okay. Yes, moving on. Yes, we'll carry on the session.
पुष्कर विजिबल है ना?
No, yes, your screen is not visible.
One second. One second, okay. Now we use front plane, sketch normal. We make a rectangle and go to the smart dimension and give the dimension. 25 mm. Go to the feature, select extrude boss base command. And put the value 10 mm. And it is converted into 3D. 2D to 3D. Now we select a surface normal. We create a hole. Select circle. And go to the feature. Select extrude cut command. Click OK. Part is good. Do all. And how to use a helix and spiral command. Select front plane, sketch normal, draw a circle. Hello?
Yes, you are audible.
No, Pushkar, I'm audible? Okay. Go to the feature and select helix and spiral curve. This is helix and spiral command. Pitch 107 mm. Revolution 15. Click OK. Sorry, distress. Here we will put 25 mm. Click OK. Go to the struct boss base command. Select circular profile. Create a 3D spring. If you guys have any question, then ask me.
Good evening, sir.
Good evening.
Yes, I want to ask that the SolidWorks that is available online, is it free for students on a student license or something? Because otherwise it is a paid course of SolidWorks that we have to buy first to use it.
Sorry, your voice is not audible. Hello.
Hello.
Yes, yes.
So I am saying that the SolidWorks this version is available for free for students or it is paid.
Yes, sir. Yes, it is free. Go to get onto PC and क्रैक वर्जन आप डाउनलोड कर सकते हो उसमें जाके.
कहाँ से सर?
गेट टू पीसी से पीसी पे जाएंगे आप तो वहाँ पे आप क्रैक वर्जन वहाँ पे डाउनलोड कर सकते हैं.
SolidWorks is also available for students for trial version, and they give you 1 year trial version, so you can go and use the student version for learning purposes. Okay, and
सर एक्चुअली आई हैव ट्राइड बट ये हो नहीं पाया था. थोड़ा टाइम पहले मैंने करके देखा स्टूडेंट वर्जन का जो 60 डेज के पहले वो.
Listen, like type your doubts in the chat box. Our team is there, will reply to your doubts, and all the doubts will be taken after the session. Let Yash finish the session first. Okay. Yash, please continue with the session.
Okay. Okay, so chamfer, how to use chamfer? Chamfer creates a bevel edge on the selected edge and faces. Select front plane. Sketch normal. We make a rectangle, okay? Select feature and go to the extrude boss base command. Click OK. Go to the fillet. Select any edge of this object like this. Here we will put 2 mm. Click OK. Shaded with the edges and shaded, okay? Display shaded view of the model. Hidden lines visible, and this is wireframe. First part of a piston. Here we will choose top plane and draw a circle and keep the diameter 45 mm and extrude it up to 3 mm thickness. Now select the top face and draw here a small circle. Let's keep the diameter 10 mm and extrude it up to 70 mm long. Now select the back surface and draw one more circle. Keep the diameter 24 mm and extrude it up to 28 mm only. Select flit, keep radius 6 mm and select the bottom edge. Now sketch front plane. Now select the center line and make two rectangles. Let's define the gap 15 mm. दोनों के बीच का जो gap रखेंगे वो हमारा 15 mm होगा. And height is 20 mm and width known anything no. Now select extruded cutter select through all both directions. Let's make a hole. Draw center line and make a circle. Diameter है हमारा 8 mm and select extruded cut through all both directions. Okay. Now we choose top plane, sketch normal. And we will make a circle. Okay. Diameter is 45 mm. And extruded up to 3 mm thickness. Okay, go to the feature and extrude was this command. And here will be put the value 3 mm. Enter. Now select the top face and draw here a small circle. Let's keep the diameter 10 mm and extrude it up to 70 mm long. Select the face and draw here a small circle. And the diameter is 10 mm and extruded up to 70 mm long. Go to the smart dimension, select circle, give the dimension 10 mm and go to the feature and use our extruded boss base command. Here will be put the value 70 mm long. Click OK. Now select the back surface and draw a one more circle. Keep the diameter 24 mm and extrude it up to 28 mm only. Now select bottom surface, sketch normal. Select circle. Here we draw one more circle. Go to this smart dimension and give the dimension is 24 mm. 24 mm. Go to the feature and use extruded boss base command. And here we will put 28 mm. And here we will use flit chamfer. How to use chamfer? Now select flit chamfer, sorry, and select this edge. And here we will put 5 mm. Now select the front plane. Now select the center line and make two rectangles. Let's define the gap 15 mm. Now we will select the front plane, sketch normal. And here we will make two rectangles. Now select center line. And here we will make a center line. Height 20 mm and width known anything. Now select extruded cut, select through all both directions. And here we will define the gap 15 mm. Select smart dimension. here we will make two rectangles randomly and select extruded, pause this command. Sorry, select extruded cut. Select through all. Select through all both directions. Click OK. So here we will cut this section and select this surface, sketch normal, and here we will create a hole. Go to the smart dimension. Give the dimension 8 mm. Now again give the dimension. Select this circle to this point. Eight mm. Now here we will cut. Go to the feature and extrude cut. Now select through all both direction. Okay. Top rod. Hello. Hello.
Yes, yes.
हाँ ये क्लियर कोई वाला?
Yes, this is clear.
Okay. Now we select it. There are different types of materials in design library. We choose metal. Here we select aluminium. This is top rod. First we will choose top plane and extrude up to 108.93 mm. Now choose flat top edge 6 mm and select front plane, draw center line, choose corner rectangle. Length is 20 mm. Select the rectangle and mirror about center line and center gap is 15 mm and select extruded cut through all both directions. Select cut face. First draw a circle, draw a center line and draw a circle is 8 mm and the distance lines from top line. Keep 10 mm, select extruded cut and select through all both directions. Draw one more circle 18 mm and go to the feature and select extruded boss base command. Keep midplane and extruded thickness 25 mm. Select bottom face and draw a circle 27 mm and select extruded boss 80.93 mm in reverse direction. Create a thread cut. Select outer edge, then go to feature and select helix and spiral curve. Height 50 mm and pitch 3 mm. Now select the right plane, select line and draw a rectangle dimension 2 mm and draw a center line. Now select the point and select this. Path angle of rectangle is 60°. Then go to the feature and select the swept cut command and select the path and select OK. Now threads are created. Shocker nut fasteners in the design library. The design library is in the taskbar and has a link to the SolidWorks toolbox, which is included with most versions of SolidWorks. The design library is filled with common components used in mechanical design and that are commonly sold by suppliers. The most common use of design library is for fastener use as screws, bolts, nuts, set screws, washers, etc. They all are available in design library. Different types of tools, gears, uh, etc. And this is bearing of top rod. Here we will choose front plane, draw a circle and give the dimension. Select feature and extrude it up to 10 mm. Select face and make another circle and give the dimension. Then go to the feature and extrude it cut command. Select front plane, sketch normal. Go to the sketch, select line, Now we will select all the lines and make equal. Select this line to this line. Go to the feature, select revolved boss base command. Now here we select the surface, sketch normal. Now we draw a circle. Go to the feature, go to the sketch and give the dimension 30 mm. Here we will give 60 mm of this rectangle. Select feature and extrude it cut. Now we select through all both direction. Click OK. We created a full hello. Hello, Pushkar.
Yes. Yes, yes, you are audible.
Okay. Then go to the assembly. And here we will cut the components. The assembly needs two or more parts. So start this rod. Now select this face. This face. And here we will use mate. Part is assemble. Click OK. Hello.
Yes, yes.
Uh,
Yeah, the assembly is done, yes.
yes, assembly is done. The lecture is over.
Okay. Guys, if you have doubts, then you can ask. So, first of all, Brandon, you were asking about the SolidWorks inventor and profession. What's the difference between all these software? So, all three of these softwares are CAD modeling software. First of all, okay. So, as I have told you earlier, that these softwares are like different programming languages. Okay, if you know the logic, how to build these things, okay, how to make this campus, the commands are same in all these softwares, okay. All the sketch commands are there, they are the same. All the feature command, be it boss, base, be it extrude, cut, sweep, all the commands are same. You just need to learn how you have to create these things, okay, how to use these commands. Baki rest, everything is just the difference in the graphic user interface. Only the interface changes, but the rest, everything is the same. So don't worry about it. You can start. SolidWorks is a easy software for beginners. So and also it is wordly, like it's acceptable worldwide. Most of the companies use SolidWorks. So you can start with SolidWorks as your first CAD software. Later on, if you want to move, then you can go for CATIA and other things. Okay. But all these softwares are like, these are the same. You just need to know how you have to develop a design intent first of all. Okay. After you have developed the design intent, you can easily design anything in any software. Don't worry about that. And rest, yeah. So you were also asking about the part. So this is a damper assembly part. Okay, so this is the piston and this is the cylinder. So like this part is done. And tell us about the free software related. Okay, so the free software is the thing. SolidWorks provides you the 60 days trial version of the software. So you can download that software and use it for 60 days. In 60 days, you can easily learn everything about SolidWorks and how to use it. You just need to be consistent, that's it. Okay, any other doubts, guys? Okay, yes, they don't have any other doubts. Thank you for the session. And I think we can conclude the session right now.
Thank you so much, all of you.
Okay. So yeah, we are concluding the session, guys. Thank you for everything. And for more details and like for learning more about SolidWorks and like other things related to EV or like any other things, you can directly go to our website at ISIEINDIA.com, and there you can find various courses related to EV, related to robotics, related to data analysis, and you can learn from there also. So thank you everyone. Thank you for giving your time. You can leave the meeting. Yes, yes, there is certificate for this course. Okay, we are having doubts. So yeah, is there a certificate for this course? Yes, yes, there is certificate for this course. You will get the certificate in your email. You can connect 3D printers and printers this one. So you, Siva, do you want to ask that can you connect 3D printer to SolidWorks? Hello, Siva? Yes, okay. So Siva, for your doubt, let me clarify you. 3D printing technology works on a file extension named .stl. Okay, .stl. So that .html, it stands for the stereolithography. Okay. So yes, the you can save that file that you create in SolidWorks. SolidWorks actual extension is .spdrt. Okay. It stands for SolidWorks-part. SPDRT. Okay. And then you can convert that, like you can also like, have you worked on Word, MS Word? So there you get an option for save as. You can either save it for a Word doc file, docs, or you can even save it as pdf. There itself in SolidWorks also you can save that file in .stl format, and that stl format file can be read by 3D printer. Okay, 3D printers, they generally give their own software in which you have to import this .stl file, and then that .stl file is later on sliced. Okay, the slicing procedure is done and later on it's printed. So yes, you can do the convert your original file that you built in SolidWorks to .stl file, and you can print it over there. Any other doubts, guys? Yes, yes, they use the same extensions. So basically in metal 3D printer and PLA 3D printers, okay. So basically they work on the same principle. They work on the same principle, just the difference is the temperature on which they work on. For metal 3D printers, they work on a very high temperature, but the principle remains the same. The slicing part and everything that remains the same. And according to different printers, like there are various companies. For example, there is a company called Race 3D. It provides its own software. It provides its own software, so like you can like just import that STL file in that software, and later on it will do the slicing and what all thing, and just you can click on start printing and it will start. Any other doubts, guys? Okay, thank you everyone. So I guess this is the end of the doubts. We are concluding the session. Thank you all for joining. Bye bye.
Yeah, thank you, Pushkar. Thank you, Yash. So, guys, anybody have any queries? You can ask, or if you want, you can also drop your queries in the chat box. Meanwhile, I'm sharing a link with you all in the chat box. So, if you want to learn more, or if you have any query, you can fill the Google form. Our counselor will get back to you soon. So, you can find the link in the chat box. So anybody who wants to learn more, and to explore more CAD softwares or EV courses, or if you have any type of queries, you can just fill the Google form. You can find in the chat box. So our counselor will get back to you. Okay, so if nobody have any queries, then we can close the session. Definitely will come in the next week with a new session, new topics. So hope till date you can just go through once again. You can also find new courses, new free courses on our website. That is at www.isieindia.com. So you can explore the world of EV at our website. You will find the numbers of free courses over there. Thanks for coming. Thanks for sparing your time with us. Thank you, guys.